you very much. A very warm welcome from my side to this presentation, Why Knowledge Chatbots Still Fail, the Hidden Pitfalls of RAG. And before I start, maybe to get a little bit of a feeling for the room, who of you knows what retrieval augmented generation or RAG is? Perfect. Who of you would feel comfortable explaining RAG to a tech person, how to optimize the system, how to make it more accurate? Still a few? Very good. Cool. Yeah, I thought that there might be quite some heterogeneity here in the room, so I'm trying to find a good balance between explaining basics and getting more concrete and more detailed. Before I do that, a quick intro on myself. My name is Lewin. I'm a co-founder of Chunkify. We built a parsing and chunking tool for high accurate RAG use cases. I have a tech co-founder, two tech co-founders. One of them was supposed to be here today. I'm the only non-tech person in the team. So I'm pretty confident that I can hold the presentation in a way that it's interesting to you. If we have questions afterwards, please don't hold them back. I'm super happy to discuss. If there's something that is very technical or too left or right to our topic and I cannot answer it, I will take it to our tech team and get back to you after the session. But please ask all the questions that you have. I'm happy to discuss. Now, I want to start this presentation rather high level and talk about the new kid on the block that everyone, even me, is talking about, even though I'm not a technician since ChatGPT launched, and that's artificial intelligence or AI. And even though it's not really sure what that even is, the promise is big. Things will become much easier. There are things that we can now develop. Everyone can basically develop software, everything becomes more easy and manageable. That was hard before, right? That's the promise, at least. So we see that many applications are now being developed across industries, across functions. I was at the health conference, DEMEA, here in Berlin a couple of weeks ago, and there was almost no booth that didn't promote their AI products, right? And 3 years ago, there were panel talks on the exact same fair on why LLMs will not be applicable in health. So you see, AI is getting everywhere now, but the problem is that even though the promises are so high, we are struggling with building AI applications that really add value. And I will get into this in more detail in my presentation, but the core reason for that looks like this. And this, what you can see, is unstructured data, and it's just on the example of research papers or PDFs. And what you can see is that the data that we try to feed in many AI applications is highly unstructured. You have tables spanning pages. You have columns that have multiple columns on individual pages. You have headlines that are completely inconsistently formatted. You have flowchart, process charts, all kinds of messy elements that make it very difficult for AI applications to make sense of. So this will be the topic of this presentation, and I will now get a little bit more deeper into it. So the problem is that when we have this unstructured data and we try to connect it, for example, to RAG systems, there are many mistakes being made by these systems. And I really liked this article. It's about a study that was being published this year, and it found that on main AI search tools, when they quote an article or they find a source, in more than 50% of the cases, there's a mistake. So the mistake can be that the wrong article or the wrong source was being found. The mistake can be that the right source was found, but then the content was interpreted in a wrong way. But there are many mistakes happening again and again. And the problem with that is that these systems are really good at creating a wow effect, right? First-time users, it's pretty easy to attract users for the first time. The systems, they kind of bring the message that they solve a problem, and when you use it for the first time, you're impressed. But then when you use it again and again, you see that these systems do these mistakes, and then users churn. And from a business perspective, that's a huge problem, because what many young companies or developers are good in are building these MVPs, but then to convert or to go into production and to convert first-time users into monthly active users or into paying customers, that's a big struggle. So the problem are these sources, and to get into that and to explain that, I want to talk a little bit about how RAG works, and I will start with the real fundamentals just real quick. So the basic idea of RAG is that you connect a large language model with an internal database. So you use the LLM for generating the text, for understanding the query of the user, but then the content itself comes from the database. And this has a lot of advantages. For example, You can manage the content more easily. You can take out files. You can add files whenever you want to. You don't need to retrain your model. It's rather cheap from a computational cost perspective. And you always have this traceability, right? You can retrieve documents, and when you quote them, you can tell the user where the content actually comes from. So many advantages and many different tools that you can think of. This is a tool that we built last year, and the idea was that we built some kind of medical chatbot for doctors. You may not know this, but doctors need to look up information all the time. That's not because doctors are stupid, but because there's just so much medical knowledge out there. And what happens in the real world is that doctors, they go to the toilet or they sit on the computer, take out their phone, and they browse manually huge documents, official guidelines, and all these kind of things to find the information that they need. So our idea was pretty simple, and there are many other companies that are doing exactly the same thing. We thought, well, we take a vector database, we put all these documents in the database, connect the chatbot to it, and then doctors can ask a specific question, and then the answer is being generated based on the content that we added to the database, right? How that works from a technical perspective is that, first of all, you need to set up your vector database. So you take all the documents that you want to include, and you do a step that's called parsing and chunking. So you try to extract all the content from the documents, then you chunk it up, you cut it into small pieces, and you embed it, which means that you transform it into vectors, you put the original content in the metadata, and you store it like this in the vector database. Now, when a user, in our case, the medical doctor, has a question, he or she answers that question into the chatbot, then something similar is happening. The content is being extracted, then probably an LLM will rephrase the question so that the process runs more smoothly. You embed the user query, so you're also transforming it into a vector. And then you're doing something that's called similarity search. So you try to find vectors in your vector database that fit to the query vector that you generated from the answer from the user. Now the system will retrieve the most relevant vectors that it finds in the vector database, let's say 20 or 30, or how many you can select. Take out the original snippets from the metadata, put it into the context window of an LLM together with the original question by the user, and then the LLM can generate an answer based on the context, on the content that you put into the context window of the LLM. Now, that all sounds pretty easy to implement, and we had, I don't know if you attended other sessions here in this room, we saw that you can build a RAG system in around 40 seconds if you use plug-and-play code that's out there. There are also no-code tools that you could use, and it all seems pretty simple. Now, the problem is that these systems typically are not very accurate. So, I mean, I showed you this article on the that evaluated the AI search engines. They say the accuracy around 50%. Let's say it's a bit better. You have a specific use case. You don't use all the data that's out there, and you maybe have an accuracy of 70% because you really worked hard to improve the accuracy. Let's think about that, right? If you have an accuracy of 70%, it means that out of 10 user queries, 3 responses are actually wrong. And now in the medical context, it's obvious that this is not acceptable. But even in other contexts, if you think of trying to build something that people will actually use, and 30% of the answers are wrong, and then critically, the users don't know which of the 30% of the answers are wrong, this will not be being used in the long term, right? It's not adding value. Now, from a developer's perspective, the problem is that we don't really know why 3 responses are wrong. There are so many different things that you can do when you plug in your RAG, or you build your RAG, that it's really difficult to pinpoint where the inaccuracy is coming from. So what you will probably do is you will ask ChatGPT, ask your colleague, go on Reddit, and check what you can do to improve the accuracy. And I want to talk about some of the levers that are generally being recommended to improve accuracy. So, first of all, you can select different LLMs, right? That's quite an obvious one. I mean, the most simple thing to do is to play around with the big models, just replace a model, see if it works better. You can also train your own model, like with a specific data set to evaluate the answer that's being generated. That comes with a lot of work and with a lot of new questions on accuracy, but that's something that you could do, right? Something else that you can do, and that's an obvious one as well, you can do prompt engineering, and you will definitely have to do that. There are many different recommendations on how to do that, but basically the idea is that you steer the LLM to interpret the data in your database in a specific way. So for example, in our case, when we have the medical chatbot, and you have a question on medication, for example, and then you retrieve some content from your vector database, you can put in a prompt the information, well, when it's about medication, always write the answer like this or like that. And by doing that, you can improve accuracy. Something else that you can do, you can play with the chunk size. I'm not so sure about this one, but you can definitely do that. There are small chunks, there are large chunks. There are whole philosophies around how to improve accuracy with chunk size. Much to steer here. Something else that you can do, which I think is quite effective, is that you can label the data. And why I think it's effective is because you can make unstructured data more structured, right? When we stick to this medical use case, for example, adding to data pieces when it's about medication or when it's referring to children, you make this data that was previously unstructured structured, and then you can add some deterministic algorithms into your RAG system to kind of prioritize data according to the user query. You can choose different embedding models. I will not get into this in too much detail, but it's also something that affects accuracy. You can do contextual retrieval. That means that you're not only trying to find the most similar vectors with your similarity search, but once you found a vector that looks similar, you're also trying to find vectors. You try to find, retrieve vectors that are around that one that you found. So for example, you can, in a very dumb way, would be to just retrieve the chunk before and after the one you identified. A more smart way would be to, for example, always retrieve the whole chapter that you identified and also put that into the context window of your LLM so that the LLM has more chance of finding the right information in the content that you retrieved. Re-ranking is something that you can do. It means that you take all the chunks that you identified and you run an LLM over it, and you tell the LLM to kind of prioritize or to assess the quality of the data that was being retrieved, compare it to the search query, and then re-rank the content, and only build the answer based on the most relevant pieces that were found. Now, there are many different things that you can do, and you will find a lot of information in all of these things when you go online or when you ask someone else. But what we found pretty surprising when we were building our medical chatbot is that something that is not being so much in focus is this first step, the data part, and here specifically the extraction and chunking part. And with the extraction and chunking, once again, what does it mean? It means you take the data that you have, you extract the content, right, and you build chunks out of it. So you cut it into small pieces. And this is often being overlooked. And the reason for that, in my opinion, is that the promise for most parsing and chunking tool looks like this. They tell you that basically you can just put all of your input. It doesn't matter how it looks like. It doesn't matter how messy it is. It doesn't matter what format it has. And you can dump it into their tool. They will parse and chunk the content and give it back to you in a kind of JSON structured form. Now, the problem with that is when you trust that statement that they are able of doing that, you will take too much data. You will just take everything that's on your drive or that you think is relevant. So you don't really know what's in your data. Then you put it into that tool and you don't really know how that tool works. So that's another black box. And then you get JSONs out, which is that your content is hidden somewhere in the code and you don't really know how that looks like, right? So what is happening here is that you have black box data, you have a black box tool, and then the output is a black box as well. And that leads to big issues. And we were struggling with accuracy with our chatbot. We were trying to improve the system by doing all the steps that I just showed to you previously. And then we started to look into the data. And what we found was really surprising to us. And I brought 3 examples. And you may think that they're exaggerated or that they are obvious. But in fact, they're not. Like if you're building a RAG system, I really recommend look into the data and how they look after you parse and chunk it. You will be surprised how messy the data gets once you use black box tools to parse and chunk it. So some examples. What you can see here, it's again kind of obvious, but it's not from our data set, but it's an example that went viral that I really like. And what you can see is that the parsing tool, it just chunked from left to right, and it didn't detect that there are 2 columns. Probably it detected it on the other pages where there was no table on top, but because there is a table on top that goes from left to right, the parsing tool probably mixed up the information that there on the lower part of the page there are 2 columns. So it builds the chunks from left to right, mixing up all this information. And what happened here is that a new sentence is being created, reading from left to right, which is what happens to the, and then vegetative, which stands here, and then on the right-hand side, electron microscopy. Now, there is no vegetative electron microscopy. However, if you go on Google Scholar, this academic search tool from Google to find papers, scientific papers, and you type in vegetative electron microscopy, you will find quite a few papers using that word. And the assumption is that probably they used some form of LLM to help them writing their paper, and the LLM was trained on badly parsed information. Another typical topic that or problem that we see is that the parsing tool it does a good job here, right? It detects, okay, there are 3 columns, even though there's a weird line going from left to right. There are 3 columns. There is a chapter starting here. That's also not very common that they actually detect that, and it starts the chunk at the beginning of the chapter. So already pretty good job. But then it stops here. And why is it doing that? I mean, I don't really know, but maybe it doesn't really know whether the sentence continues in the middle of the page or on the next page that also has 3 columns, or maybe there are only 2 columns on the next page, and therefore the parsing tool is completely confused. We don't know, but the problem is that it cuts the chunk here. And by doing that, the sentence doesn't make any sense anymore, right? It says there is an increased risk for what? We don't know. Now you can imagine when a researcher asks a scientific chatbot for the increased risk of XYZ, it will be very difficult to retrieve that information because the context is getting lost by building a chunk like this. Another mistake that can happen, and that's happening basically with all parsing and chunking tools out there, is that they don't really understand the whole structure of the document. And here what we can see, it's the Dutch building code. And I like the document a lot because they have very weird headlines. Some chapters, I think, start with chapter 1, and then the title, chapter 2. And then you have subheadlines that don't have any indication anymore that it's a headline. It's just a bolded text. Then you have enumeration that is here intended on the left. And the parsing tool apparently was a bit confused where the headlines are, and it didn't recognize them. So it just built a chunk by this list item, the person doing the building work. So when you have this piece of information in your vector database, it doesn't mean anything, right? It is important to note that in the headline it says that for the process XYZ persons, the following persons are responsible. Only if you detect that headline, the chunk itself will make sense, and only if you have that, the RAG has a chance of generating a correct answer. Now, what happens when we dump all our data into these tools and we get chunks like this back? It's just a stupid example from the airline industry. But imagine a passenger going on the website of an imaginary airline and asking the question, can I bring 2 carry-ons on my flight to New York? Now, the chatbot or the RAG system will retrieve that information, build a vector, make a similarity search, and it finds something that looks very promising, right? It's a snippet in the vector database that says passengers can bring 2 suitcases and 2 carry-ons. So it's a perfect match. The information is being retrieved. All of this goes into the context window of an LLM. An answer is being generated. Yes, passengers can bring 2 carry-ons and 2 suitcases. Now, the problem is that the parsing tool, when we set up this chatbot, missed the headline. 3 pages before, there was a bolded word that said, section, luggage guidelines for business class passengers. So you can imagine this information is wrong. The customer is super frustrated and will say, I will never use this chatbot again. I will always call the hotline. Problem not solved, right? This is kind of a stupid example, but think of our medical chatbot. We have this guideline for disease XYZ, and then on page 250, you have a headline that says, don't do this, or the following section applies to kids or to children. And then you have from page 151 to 159 information that only refers to children. If you miss that headline, all the information in your database will be meaningless, and there will be answers being generated that are eventually wrong. So it is super important to really understand the document and to really preserve the information that was encoded in this unstructured data in the first place, so that the RAG system has a chance to be accurate. Now, what happens if you have bad data quality and you try to increase the accuracy by doing the other steps that I showed to you? Well, you can make it better, but only to a certain extent, and sometimes you can make things even worse. For example, one recommendation is that you build overlapping chunks. That means that you have a chunk and then another chunk, and you overlap them, right? So you have more information in each of the chunks. And the dumb hope here is that by overlapping the chunks, you somehow will get meaningful chunks for the interpretation for the LLM. Now, the problem is that eventually, if you have a parse tool where you, for example, parse across columns, you will just increase the noise and worsen the problem because there's even more nonsense that the LLM needs to figure out. Another strategy is to build larger chunks, then to run an LLM over it for summarization and attach the summary to the chunk so that in some way there's more meaning in the chunk. Now the problem is if you have super bad data quality and you force an LLM to summarize, what will happen? The LLM will hallucinate, right? So the data quality again will get worse and you will have struggles of building or fixing that downstream when you have accuracy issues. And then you get the point, but another thing is contextual retrieval. So you try to find more information that is relevant around the chunks that you identified. Now, if the data quality is worse, you can potentially even retrieve even more nonsense, which doesn't help to fix your accuracy issues. So what can we do to build better RAG systems? And yeah, I mean, that's now very non-tech, but maybe and high level, but I think it's super important. So I think what is super important is to really think about the use case that you want to build, really think about the pain point that you're trying to address, and really to nail it down to a very specific thing. And once you have that, decide on which tool you want to develop in order to address that pain point. And then on a third step, think about the data that you need to lift that problem that you identified, right? And in our case, for the medical chatbot, and I think that's often the case, that you could add a lot of information to the RAG system, but only a small part of this is really relevant to your use case. So for this medical chatbot, we have, for example, official guidelines, right? Doctors are recommended to treat according to official guidelines, so these are super important documents. We added those. Then we have official information from pharmaceutical companies, also very relevant for medication, so we added those. And then we have all the scientific papers out there in the medical world, which is probably 95% of the data. And here we said, do doctors really treat according to newest scientific papers? They're probably not. Probably the doctor in the hospital, they want something that's being recommended by the association. It's a nice to have, but you don't really need it. So what we did is we focused on this 5% of the data, and we really made sure that the data quality is extremely high after parsing and chunking. And all the other stuff we either excluded or we parse and chunk it with a like 80-20 approach. But when we generate an answer based on that badly parsed and chunked content, we label that for the user and say, well, maybe double check it before using it. So for data, don't use all available data, don't process the data blindly, and don't skip the cleaning part. So basically don't trust what parsing and chunking tools are promising. If you look into the data, you will be really surprised how much information gets lost by parsing and chunking. Instead, it's important to identify and prioritize relevant data to prepare and process it with care. That's kind of obvious, I think, after this presentation, and maintaining the pipeline continuously also helps. So how does a good chunk look like? I mean, first of all, you need the content itself. I think that's an obvious one. It can be long or small. That depends a bit on the use case and also on the data that you have, what makes sense. But then it's really important that you understand the document structure and you add all the information that you need so that the pieces that you cut out make sense. So for example, you need all the headlines. And I'm not talking about the headline that's the next or the next above or the ones below, but really all the headlines. So on the level 1, in this airline example, it's luggage guidelines, and then there's a level 4.1, so a second level, and there can be easily 6 to 7 levels in a normal document. You need to include all the headlines. Then it's important to retrieve footnotes, for example. That's a tricky one. You often have in tables, you have headlines within tables. If you don't spot them and you don't add them into your chunks, you will render the use case meaningless. And then there's a lot of metadata that is interesting. For example, if you're doing the parsing correct and you detect all the headlines correctly, you can do something like some contextual retrieval, like retrieve, for example, always a full chapter, because you do know where the chunk is located and where the other chunks are and whether they belong to the chapter or not. Yeah, now these are 3 company examples. For 2, I'm completely unbiased. For the last one, I'm a bit biased, so I will be really quick. Those ones I like because they're taking a little bit of a different approach. I mean, there are tools like this being launched it feels like on a weekly basis. But what they do a little bit different is that they try to read the document like a human with an LLM or with an OCR, and they lift that black box. So with Aaron, you see the document, and you see how they identify the elements, and then you see all the mistakes that they're doing, and then you can go into your chunks and fix them, right? And it's pretty accurate. In the first place, I think they're also automatically taking the pictures and translating them and all these kind of things. Then there's another tool that I just learned about on this conference. I think it's not live yet. It's Parksy, and what they do is they want to build an API that connects so that you can dump in your data, and then they send it to different parsing tools and evaluate how efficient it works. And then you can choose the right parsing tool depending on the data that you have. And then lastly, and this is the one where I'm biased, so you need to take this with caution. It's our tool, Chunkify. We are not live yet. We built that for our medical chatbot, and we are now thinking of pivoting to this, but we are not 100% sure yet. But what it does is also that it preserves all this hierarchy of the document, and then you can tell the tool how the document looks like, so that it can then understand the document better and build meaningful chunks. And you can try it for free if you want to. You can contact me. So long story short is, and the point of this presentation, you need to look on your data in the first place. And once you did that, and once you extracted all the information and you built meaningful chunks, in the next step, you can focus on this. And you cannot skip this. All of this is also important to build accurate systems, but it is absolutely necessary to look at your data before you do all of the other things. And what we see all the time is that everyone focuses on the violet part and forgets to look at the data, because it's a huge pain, but it is necessary in order to really develop systems that work. So first fix your data, then fix your RAG, I think is a key takeaway. And with that, I want to end this presentation. Thank you.
Thank you so much. Yeah, that was quick.
Was I first or? Okay. So I understand that like unleashing, let's say, a generic chunker on whatever PDF may lead to rather underwhelming results. But at least when it comes to scientific papers, they tend to have one of three layouts, basically. They tend to be very standardized, right? Mm-hmm. Why is that domain still like that problematic?
Yeah, that's a good question. So, I mean, there are a lot of parsing tools that try to reflect that, right? So you can kind of, when you upload your data, you can say, well, this is a research paper, and then they try to probably adjust their parsing algorithm in the backend to match that style. But I think when we think of document structure, we have something in mind, right? You see a research paper, you think, okay, there's a title and abstract, and then there are like 3 columns, and they're probably kind of the same. If you really look at research papers and you print them out or you look on them on the computer, you will see that the variety is just endless. Some authors build headlines that are bolded, some are italic, some are in the paragraph, some are not. PDFs tend to be so messy that they make sense for us as humans when we read them, because we kind of see the information and can solve this computing with our brain. But if you give this to a parsing tool, they will make a lot of mistakes. And you will see that, like, especially with research paper, there's so much content in there, headlines of pictures and all these kind of things, that in the end are very difficult actually to interpret correctly. And then also, speaking of headlines, you often have this headline hierarchy, right? You have different headlines, and then you need to make sure that this hierarchy is preserved. But if the headlines are formatted inconsistently across papers, but also within the same paper, often the headlines are inconsistently formatted, and sometimes even the authors made mistakes that don't really catch our attention when we read them, because we read the paper and we are on page 20 and we see a bolded headline and it kind of makes sense that it's bolded. I understand it. But if you really, like you map the headlines on a tree, this bolded one is a level too much high or too much below. So even even when it is structured and it makes sense for us, if you read it out and you try to bring it into a logical structure, there are often, even if it's formatted correctly, there are mistakes that you need to fix so that you have the relevant input in your chunks. Yeah.
Okay, we had a question from the folks at home. Where can we find more info about Chunkify? Website, social, something?
You can add me on LinkedIn. And there's chunkify.io, but it's a bit preliminary. But you can check out the website, yeah.
Okay. Yeah, questions from... yeah, there's a question back there. 1 second.
So what do you do for other modalities like images in the PDF or the table or the graph? Do you do anything on that?
Yeah, I mean, you have to, right, in order to make sense out of it. And I think there are different approaches, but what you can do for everything that becomes too complex, so for example, process charts or pictures, what you can do is you can cut them out of the document, and then you have the coordinates, right? And when you attach the right headlines to that cutout piece, you can send it to an LLM for interpretation, and then you can embed the kind of summary, and then put the original picture in the metadata. And then when there's a question being asked, the LLM can still find the relevant content. Then you just retrieve kind of the picture of that picture, so to say. For tables, I think there are different parsing tools out there that work better or worse with tables. So it definitely makes sense to select the right parsing tool for your tables. And tables are a whole beast, I can say, because you have crazy tables that are really, as a human, even difficult to understand. For example, in the medical world, you often have tables that you have different columns, right, and then different rows. So you need to, if you cut out a row, you need to make sure that the context is preserved. So you need the columns header and the headers in the row. But then you have crazy merged cells that are also relevant to interpret the data, right? And if you have a number like 60% somewhere here, you need to make sure you catch all the subheadlines and the headlines in the table, in the columns. And that's super difficult to do. But you need to, yeah, if you need that data, it's important to get that right. Yeah. And if you have large amounts, you will also be surprised how much like visual models, how many mistakes they actually do, especially if you have a lot of data in your table. Yeah.
Great. Another question from home. You touched it a little bit, but if you can share what libraries or models are you using to extract the text itself?
Which one to use in general?
Which one are you using if you're willing to share? In
our tool, we have our own algorithm, but I think in general there are many different open source tools that you can use, like PDF Miner or others. But I can take that question to our tech team also and get back to that.
Okay. So the person who wrote it, maybe you can write it in the chat and.
Do I have access to that?
To the chat, yes.
Yeah. Cool.
Any other questions from the audience here or at home? Okay, awesome. Again, big round of applause. Thank you so much.
Thank you very much.